Is your dog more prone to accidents lately? And are you noticing that it takes longer for them to heal from these accidents? Well, it could be something more serious than you think. They might have something called von Willebrand's disease. So today we will be talking about von Willebrand's disease, and we will explain everything that you need to know about this disease and how it will impact your dog's health.
What is von Willebrand disease? Von Willebrand disease is the result of the deficiency and/or abnormality of von Willebrand factor with decreased levels of factor VIII, a large multimeric adhesive plasma glycoprotein critical that plays an essential role in both primary and secondary hemostasis. There are three types of von Willebrand disease. Type 1 is caused by a partial quantitative deficiency of von Willebrand factor. Type 2 is an autosomal dominant disease caused by several qualitative defects in von Willebrand factor. Type 3 is when the von Willebrand factor levels are not detectable. But what does that all mean?
This is a blood vessel, and its job is to allow blood to flow smoothly throughout the body. The blood vessel has two layers, endothelium layer and under that the subendothelium layer. The endothelium layer is full of anticoagulants which allows blood to flow through smoothly by preventing clogging. The subendothelium is full of coagulating agents, von Willebrand factor and proteins, with a main role to coagulate. When the endothelium layer of the blood vessel gets damaged, say from a bruise, it's the subendothelium layer's job to heal the blood vessel by using coagulating agents, proteins, and von Willebrand factor to return it to hemostasis. However, von Willebrand disease prevents that from happening effectively. There are two stages of hemostasis when it comes to von Willebrand disease: primary and secondary hemostasis.
Primary hemostasis is the body's immediate response to blood vessel injury and plays a crucial role in preventing excessive blood loss. It involves the rapid formation of a temporary platelet plug at the site of damage. When a vessel is injured, the subendothelium layer becomes exposed, triggering the release of chemical signals including cytokines and inflammatory mediators. These signals help attract circulating platelets to the site. A key protein in this process is von Willebrand's factor, which binds to the exposed collagen in the damaged endothelium layer. Von Willebrand factor acts like a bridge, enabling platelets to stick to the injured area. Once adhered, platelets are activated. They change shape and release substances such as thrombin, thromboxane A2, and adenosine diphosphate. These substances serve as chemical messengers that recruit additional platelets and enhance their ability to clump together. These signals act through specific receptors on the platelet surface, including G protein-coupled receptors and integrins. The activation of these receptors causes further shape change and increases the binding strength between platelets, forming a stable layered plug. This plug is reinforced by a mesh of fibrin, making it strong enough to withstand the pressure of blood flow. In such conditions such as von Willebrand's disease, where the von Willebrand factor is absent or deficient, platelet adhesion is impaired. As a result, the platelet plug cannot form properly, leading to prolonged bleeding even from minor injuries. This highlights the critical importance of von Willebrand's factor and platelet function in maintaining vascular integrity.
Secondary hemostasis is the process that strengthens and stabilizes the initial platelet plug formed during primary hemostasis. It involves a sequence of enzyme-driven reactions known as the coagulation cascade. In this process, inactive proteins in the blood called clotting factor are activated in a specific order. This reaction occurs through two starting pathways: the intrinsic pathway, which is triggered by damage inside the blood vessel, and the extrinsic pathway activated by external trauma. Both pathways eventually merge into a shared route known as the common pathway. A key event in this cascade is the conversion of fibrinogen into fibrin, a protein that forms a mesh to stabilize the blood clot. This occurs through the action of thrombin, which is generated from its inactive form, prothrombin, by the prothrombinase complex. The final clot is strengthened when factor 13 forms cross links between fibrin strands. Within the intrinsic pathway, van Willebrands factor is essential for stabilize factor 8, protecting it from breakdown and helping it participate in forming a protein complex needed to activate factor 10. This step is crucial for continue the cascade and generate thrombin and fibrin. In von Willebrands disease, a deficient or dysfunction of von Willebrands factor impairs its ability to bind and protect factor 8. As a result, the cascade cannot progress efficiently, reducing fibrin production and leading to delayed clot formation. This increases the risk of prolonged bleeding and slow wound healing, even with minor injuries.
Von Willebrands disease in dogs are inherited from one or both parents, with it recorded to occur in over 40 breeds of dogs, such as German Shepherd, Scottish Terrier, Golden Retriever, and much more. But don't let this discourage you, because dogs with von Willebrands disease can live a long, healthy life with the right treatment. So, if your dogs are showing signs of these symptoms, then you may need to go to the vet and get your dog checked out.